Hello everyone. In this video, we're going to be evaluating an algebraic expression. We have x squared plus 1 over x squared, and that is equal to root 2. And we're supposed to evaluate x to the 40th power minus 1 over x to the 40th power. So that's a pretty large number. And you might be thinking, oh, can I just raise both sides to the 20th power? Yes, but that would be time consuming, right? Obviously, you don't want to do that. So instead, let's go ahead and try something else. We can actually talk about two methods here. One method would be try to find the x value. Let's go ahead and go with that first. And to find the x value, I'm going to go ahead and use substitution, right? Since this is going to be a biquadratic, let's go ahead and replace x squared with something like t. And then we're going to be getting t plus 1 over t equals root 2. Multiply everything by t. T squared plus 1 equals root 2t. And then t squared minus root 2t plus 1 equals 0. Awesome. Now, we can go ahead and solve this using the quadratic formula, which is going to give us negative b plus minus the square root of b squared, which is 2. You got to be careful, you're squaring a radical. 2 minus 4, which is negative 2, but that can be written as root 2 times I. So, yes, the solutions are going to be complex, non-real, okay? And obviously, we can write this as root 2 over 2 plus minus root 2 over 2 multiplied by I in the most standard form. Okay, or is that the rectangular form as well? Anyway, something like that. So notice that this is actually a really nice complex number because its real and imaginary parts are either equal or they're opposites, which tells us when you graph this or plot this, it's either going to look like this or like this, right? Either first or fourth quadrant. And what does that tell you in terms of the argument, the angle? It's either pi over 4 or negative pi over 4, but I can also express it as 7 pi over 4, right? Great. In other words, 315 degrees. Okay, radians is a little easier, I guess. So, which value of t should be used? I think it doesn't matter, so why don't we go with the positive one because it's more positive. So let's go ahead and go with this one. So how can I write this? Well, I said that the angle is pi over 4, but what about the modulus, the absolute value? Well, the modulus in this case is going to be 1, because if you pay attention, this is cosine pi over 4, and this is sine pi over 4. You see what I'm talking about? Yes. So the modulus is 1. This is cool. And now I can basically write this using Euler's form as e to the power I times pi over 4. How nice, right? Using complex numbers. If you like complex numbers, go ahead and check out my other channel. What is it called? aplusbi. Okay? Cool, cool. Now, this is the t value, but what is t? T is x squared. Awesome. That just brings another level. So let's go ahead and set t equals to x squared. X squared equals t. T is equal to e to the power I pi over 4. Now, a complex number has 2 square roots, but let's just go with 1. I know I'm kind of oversimplifying things here, but I don't want to keep it too long. Hopefully, you can do the rest, right? I mean, there should be something that you can do on your own, right? Hopefully. But if you have any questions, please let us know. So when you take the square roots, you're going to get one of them is going to be e to the power I times pi over 8. So you basically cut the angle in half. And of course, the modulus is 1. So its square root is also going to be 1 here. That's why I don't have to worry about it. And the other root, square root, is found by adding pi to this angle. Because what happens is the square roots are actually going to be equally spaced on a circle. In this case, the unit circle. So the difference in the arguments is going to be pi radians. So the second one, which you can call x sub 1 and x sub 2, is going to be pi plus that. So that's going to be I times 9 pi over 8. But again, for simplicity's sake, let's go with this guy here. So that's my x value. What am I supposed to do with that? Evaluate the 40th power. Yay. It's not going to be hard at all. Look. That's what's beautiful about complex numbers. If x is equal to e to the power I times pi over 8, then x to the power 40, I'm just going to raise both sides to the 40th power. And with the exponential, it's going to be super duper easy. All you have to do is just multiply these, and 8 goes into 45 times. I'm getting 5 pi. What is 5 pi? It's bigger than pi. It has 2 times 2 pi plus pi. 2 pi is kind of equivalent to 0. Forget about it and just go with pi. So we can write this as e to the power I pi. Of course, you can always add multiples of 2 pi. So if you want to write it as e to the power I times pi plus 2k pi, that's fine too. No big deal, okay? But I'm going to get a numerical value from here. So it doesn't matter which value or branch or cut or whatever I choose, because it's always going to be the same thing in the real world. And what is e to the power I pi, right? Let's talk about it. Well, we kind of talked about it in another problem, but if you think about it, e to the I pi is a complex number whose argument is pi radians and modulus 1. So it's just going to be -1. Good old -1, yay. So x to the 40th power, wait a minute, can the 40th power of a number be negative? Of course, in the complex world, anything is possible. So x to the 40th is -1. But wait a minute, what am I trying to evaluate? X to the 40 minus 1 over x to the 40. X to the 40 is -1. This is minus 1 over -1. And that is just -1 plus 1. And that is 0. Yay! How is that possible, right? Well, if you think about it, you'll find out x to the 40 equals 1 over x to the 40, because x to the 80th power is 1, because it's e to the power 2 pi I. Makes sense? Which is good old 1. Now, that's basically one way to look at it. Let's go ahead and take a look at the second method, shall we? All right, so for my second method, I'm going to use a different approach, obviously, right? So we do have x plus 1 over x is equal to √2. Was that the problem? I forgot. And then we're supposed to evaluate this. So let's go ahead and do the following. Instead of kind of going with the actual values of x, which we found in the complex world, let's go ahead. I was just checking. Okay, I was wrong because it's supposed to be x squared. See? Now, this is what the problem is asking for. So here's what I'm going to do. I'm going to do x to the 4th plus 1 equals √2x squared. So I multiply everything by x squared this time, and isolated x to the 4th and wrote it as square root of 2x squared minus 1. Now, here's the thing. I don't want to go to x. I don't want to take square roots. I don't want to deal with complex numbers. I just want to do it in a polynomial way, okay? Here's how. I can go ahead and get to 40th power by raising both sides to the 10th power, but that would be cumbersome. So instead, let's just square both sides. How about that? That won't be too bad, right? This would give me x to the 8th power. And then if you square this like a minus b, you're going to get 2x to the 4th minus 2 √2x squared plus 1. And then x to the 4th, remember, can be replaced with this. So I'm going to do that one more time. 2 times √2x squared minus 1 minus 2 √2x squared plus 1. And then this is going to give me something super nice. 2 √2x squared minus 2 minus 2 √2x squared plus 1. And guess what? This is going to give you x to the 8th power equals -1. And is that awesome? Because I can raise this to the 5th power and get the x to the 40th power from here. Easy, right? Okay. Now we're going to get... Notice that something interesting about real and complex numbers. When you have a real number, you can write it kind of like complexify it and write it with the e to the power something. And a complex number is going to have 2 square roots, 3 cube roots, 4 fourth roots, so on and so forth. But when you raise it to a certain power, the answer is going to be unique. Make sense? If you ignore the thetas and the arguments and all that stuff. So here, x to the 40th is going to be -1. And then we're going to get the same answer because we're looking for x to the 40th minus 1 over x to the 40th, which is -1 plus 1. And that's going to be 0 one more time. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.